Hello, thank you for joining today's section on functional safety. My name is Daniel, and in today's section, we'll be looking at IEC 61511 standard, explained for process plant managers. This is going to be part one of a 7-part video series. And I would like to start by asking, what is IEC 61511 standard all about? So, IEC 61511 standard is an international functional safety standard for the process industry sector. It is a framework that guides us, the engineers, in designing, installing, commissioning, and validating safety instrumented systems in the process industry. It also guides the operations and maintenance team in operations and maintenance of safety instrumented systems. This IEC 61511 standard has a parent standard, which is IEC 61508. The IEC 61508 is the basic standard that applies to all industries. But remember that every industry has unique challenges, unique risks, unique requirements. And that is the reason why IEC 61511 was derived from the parent standard, to have a specific framework, that addresses the risk reduction requirements in a process application. Alongside the nuclear industry, they have theirs. The machinery safety, they have theirs. And because the requirements are unique, that's why in process industry, you'll be hearing things like safety integrity level 1 to 4, whereas on other industry applications like the machinery safety, you'll be hearing performance level A to E. Even when we are carrying out C verification or performance level verification, the tools we use, the software, they are all different. Like in machinery safety, you will be seeing things like the Systema software for performance level verification. That's what we use for machinery safety. But the point to note is that each industry have their own requirements, their own unique requirements. That's why the standard has been derived, tailored to the different industries. And we are concentrating on the IEC 61511 standard for the process industry, which is where I and my team, where we belong. Another question that I would want us to look into is functional safety. What is it all about? What is functional safety? So functional safety is part of the overall safety relating to the process and the basic process control system, which depends on the correct functioning of the safety instrumented system and other protection layers. And this brings us to looking at the layers of protections we have. So credit to CHE for these amazing visuals. So the first layer of protection is the process design. Process engineers, they do great job in designing safe process and safe systems, safe plant. By doing that, I've already eliminated a lot of risks. So the second layer is the BPCS. That's the basic process control system. If you take your mind back to your plants, like in the oil and gas, like the scrubbers, the KODs, that the knockout drums, the separators, the produced water, or just any process vessel or process tank, as an instance, where you have probably you are trying to control the level in that vessel or tank. So you will have your level transmitter connected to the input card of your PLC or the DCS. Then you will also have your level control valve, the pump, those outputs that will be connected to the output card of the PLC or the DCS. Okay, so the essence of the BPCS is to carry out basic process control, the level control in that vessel. The next layer will be the alarms and operator intervention. When there is a failure, maybe instrument failure or process deviation, maybe some parameters deviated from the design intent, the BPCS will populate an alarm on the DCS or on the HMI or the SCADA Now, it's the responsibility of the operator to quickly react to that alarm, which could be to adjust process parameter, or it could be to stop an equipment, can even be to initiate an emergency shutdown procedure. If all that fails, the next layer of protection is safety instrumented system, the SIS. So what it does is to try to trim the process and bring the process to a safe state. That's the primary function of SIS. The next layer of protection is the physical protection, like the relief devices, your pressure safety valve, for instance. So what it does is to try to limit the pressure from exceeding the safe limit. So if it exceeds that threshold or that safe limit, it now releases the excess pressure or the excess process fluid. I would like to point out that from this good process design up to this, we are having active protection layers, and it's for prevention. When this thing is already occurring, prevention has failed. So what do we do? Mitigation. So that's why we have other layers of protection here to mitigate, to limit the escalation of the hazardous event. Now, assuming all these they have already failed, then the physical containment, like the bonds, this bond that used to surround the process vessels or the tank. I think I have a visual here. I have a picture of one. So if you look at this wall here that surrounds the tank, so that's bond. So if there's a loss of containment from these tanks, then it will try to contain it. Why the operations team and the emergency team, they are trying to limit the escalation. That's also a layer of protection. The next layer of protection is the fire and gas system. So fire and gas system is very, very important. So what it does, trigger an alarm, to alert the personnel on board or in the process facility that there is fire on the mountain. Sorry to use that word anyways. That there is a hazardous event, okay? So then it can as well isolate some valves. The signal from the fire gas system can be used to isolate some valves or some systems. It can also be used to initiate fire suppressants. After fire and gas system, the next layer of protection is the plant emergency response. So every plant should have an emergency response team, well trained and equipped. So when there is such hazardous situation or event, they know what to do to try to limit the escalation. If the situation has gotten out of hand, maybe there is spillage or fire explosion, which is now probably affecting surrounding community. So the community emergency response and also public agencies like fire and rescue services will try to support to see how to reduce fatality. I hope you enjoyed this. Thank you for your time, and see you on the next one. Cheers.